Hi students, this is your lesson for Unit 1, Day 4, and we are going to go ahead and have you take these notes ahead of time, and then when we're in class, we're going to start with some examples and answer any questions you might have. So when you're taking notes, please be sure to jot those questions down. All right, I'm going to get through a bunch of these beginning slides because that is not part of the lesson, and here we go, we're getting into the pit. So your learning goal, and obviously please pause so that you can write down this information. Your learning goal is that you can graph a piecewise function and also that you can identify the location and describe the type of discontinuity of a function given the graph or the equation. So those are our goals for today. Criteria for success. So we talked about this one last time, graphing a piecewise function. We're going to make sure each part is in the correct domain area. The discontinuities or continuous connections are shown clearly, the end behavior shown clearly, and the shape of the function is appropriate. Okay, so the first thing we're going to talk about is discontinuities. There are 3 of them that you will learn this year. So there's a jump discontinuity, and it's just like it sounds. So this is going right here, and then we see if we're coming back to the right. So let's say we're coming from the left to the right, we would jump down. There happens to be an open circle here, and we would continue on our way. So jump discontinuity would look something like this, and we've had examples like this recently. These are called removable discontinuities. So basically you're going along like everything's just fine, and then there's just one little hiccup, and then you keep going. This case, same thing, going along, everything's fine, one little hiccup, and you keep going. So there's that one little hole that's kind of a bump in the road there for you, okay? It may have a solid point somewhere else, so it is defined, in this case, at value C, or C might be undefined. There's not a value that corresponds with that input. The last one is an infinite discontinuity. So you're going to see these when you have vertical asymptotes. So you see that there is a discontinuity. So remember, when you have to pick your pen or pencil up to finish the graph, that means it's not continuous. So in all 3 of these cases, I wouldn't be able to draw it just in one swoop. I'd have to pick up my pencil and go to the next piece. And you can see what's causing that to happen is a vertical asymptote. Okay, so we're going to get right into it. We're going to graph 2 of these in your notes right now. And then, like I said, when we go to class, we will do some more all together and take your questions. So I'm going to graph each of these pieces in a different color to hopefully help with our notes here. We have a window where x is between 6 and -4. So all that means is we want to go ahead and plot those points, and we're basically looking at the graph between -4 and 6. That's your window. That's where we're really looking into what's happening with this piecewise function. Okay, so let's go ahead and get started with our first piece. So this says you're going to use this linear piece if your inputs are less than or equal to -2. So I'm going to have -4, -3, and -2. And all I'm going to do is plug those right into this function where you see x. So I would get -12, -9, -6. Okay, so that's my first piece. Now my second piece is quadratic, and we use that quadratic piece between -2 and 4, not including -2 or 4. But remember, we need to see if there's a hole where the location might be. So I am actually going to do -2, -1, 0. Do I really want to do all these points? Not really. Maybe I'll do a 2 and a 4. And I can always put more in if I want to. So for the -2, when I plug that in for x right here, I'm going to get half of 4, which is 2, so I would get a 6. If I plug in -1, I get 1 times a half is a half, so I get 4.5. If I plug in 0, I get 4. If I plug in 2, I get half of 4 is 2, I get a 6. And if I plug in 4, I get, let's see, 16, half of that is 8, and I get 12. Now what I'm going to be sure to mark here is that this is open and this is open. Those points are just there to show where those open circles are. And I am way out of room. Okay, continuing on. Let's go with orange. We are going to use this cubic when x is greater than or equal to 4. So here I get to use 4, and I'll do 5 and 6. And we'll plug these in again right where x is, and we will do order of operations. Now you can certainly show your substitution, and if you're having trouble with keeping things organized, that was definitely a good idea. So if I put the 4 in, I get -1 cubed is -1. That's 4. That's 12. When I plug in 5, I get 0. That's a nice one, so I just get 8. And when I plug in 6, I get 4. Now we're going to go ahead and graph. So again, I should only see the line for inputs less than or equal to -2. So let's see here. When I plug in -2, I do get -6. So this is a valid point. It's not open. -3, I get -9. And -4 is -12. It's a little bit off the graph here. And we're going to go ahead and it's going to hit the edge, and that's the line. Now, if it was just this line, we would go ahead and extend it in both directions. But this piecewise function says only use the linear piece for inputs less than or equal to -2. Okay, we're going to go ahead and do the blue part, which is our quadratic. So the first thing here is when I plug in -2, I get 6, but remember, that is an open circle. But we need it there because we get very close to that open circle. So we need it there to kind of hold that spot. -1, we would get 4.5, 0, 4. Let's see, then I plugged in 2 and I got 6. And I plugged in 4 and I got an open circle at 12. Now we know that there is symmetry with these parabolas. So when I'm looking at this now, I'm like, oh, you know what? I'm going to put this one in here too because we know that this guy is our vertex. Oh my goodness. Hold on a second. Okay. So we're going to try to make a nice curve, and that's when we're showing the appropriate shape of the function. Okay, last piece is a cubic. So for the cubic, 412 is an actual point. Now look what happened. I filled that right in. So there was an open and a closed point at the same exact spot. So if you're graphing this, let's say with pencil, I would never be able to tell that was an open circle there. It would just be closed because it's filled with that cubic point. Then we're here at 5, 8. And we're here at 6, 4. So in this case, 5, 8 is the anchor point, if you will. And so this is going to look something like this, and it's going to keep on going. It's negative out in the front, which means it's reflected with that -4. And so we have that cubic that continues on to -infinity. Now the next thing is asking us, can we find the domain and range and the type of discontinuity and location? So we have lots of things that we can find. So for our domain, and we're going to use our interval notation, we have, sorry, my timer is going off. My goodness, one moment. Turn that off, and let's keep going. Okay, so our domain is, let's see here, looks like all real numbers. There's no issues. We can plug everything for an input in. So we are going to say -infinity to +infinity. That is all real numbers. The range. So the range, for this one, looks like we have a maximum and then everything else is going to be below that. And our maximum is up here at 12. So we're going to say the range is from -infinity all the way up to 12 with a bracket. We include 12. Okay, type of discontinuity. So for the type, this is a jump. And you can look back at those pictures to kind of refresh. the location is at the X value. And every year I have students, this is a tricky part for them. So the location is not the actual point, it's where is the input causing this discontinuity. It's the input of -2. So this is the location at the input of -2. Okay, second graph, here we go. So we have, again, a window between -4 and 5. So we're concentrating between -4 and 5 right here. We have a quadratic function, a linear function, and a constant function. So we're going to go ahead and graph all three of these. So here is our quadratic, and let's go ahead and make our table to back up our functions. Make sure we have these points here, x and f of x. So let's start here at -4. Maybe I'll put in, let's see, -2, 0, and 1. And we'll put these values in for the quadratic. Now, you should at least have, I would say, probably 3 points for each one of these pieces. When I'm looking at this parabola, I'm seeing that the vertex is at 0, 2. So I really wanted to have 0 in here. And then you can continue to use the symmetry. And I didn't change my color to orange. Oopsies. Okay, so we have -4, -2. I'm making this worse. 0 and 1. All right, when I plug in -4, I get 18. When I plug in -2, I get 6, 0, 2. And when I plug in 1, I get 3. Okay, now remember we need to look for that open circle. And I see it's going to be here at 1 and at 3. So this linear piece is used between 1 and 3, not including either of those. So let's say we're just going to do 1, 2, 3. When I substitute 1, I get 5, and I will write open. When I plug in 2, I get 6. That's a real point. That's okay. And when I plug in 3, I get 7. Again, this is open. We want to make sure to write that down so we don't get confused and plot the point accidentally. Okay, this is a constant function where the inputs are greater than 3. So again, we want this 3. Now look what this weird thing is. 3 is not included here or here. Okay, so when I plug in 3, first of all, there's nothing to plug in because there's no x value. So it's just 7, but this is open. Then if I put in 4, I get 7. If I plug in 5, I get 7. It's a constant function. So let's take a look at how this is going to look on a graph. So you really want to know the shape and what you're drawing here. So in the orange, I know it's quadratic. I know that this parabola has a vertex at 0, 2. Then I'd have 1, 3. It says -2, 6 is what we had planned out here. And -4, 18 is way up here somewhere. Okay, so I am going to use a bit of symmetry to get this other point here. And now I'm kind of feeling like, I kind of wish I had put in -3. Let's see. That becomes -3, 11. So I think I'm going to go ahead and plot that one. And now I'm going to try to make a nice curve. And this is going up forever, curving here and stopping right there. So we only use the parabola for that region. Okay, now let's go to our linear piece. So for the linear piece, we have 1, 5 open. We have 2, 6 closed, and we have 3, 7 open. So it's just going to be this little segment. Okay, and the last one is saying use this constant of 7 for anything greater than 3. Notice we have this open again at 3, 7. And then we have 4, 7, 5, 7, and it goes anything greater than 3. So we're going to put an arrow right here. Okay, so let's now take a look at our domain. I don't want pink again, let's do blue. So the domain, can I use all real numbers? There's one number I can't use, and it's right here. The input of 3 is not defined. Everything else you're allowed to use as an input. So we're going to say here's the domain from negative infinity up until 3, not including 3. That's why we have a parentheses. Union, that means or, here's the other chunk, from 3 to infinity. So this is really saying all real numbers that are not equal to 3, and this is how we would write it with that notation. For the range, I do see a minimum, and then I see we're going up to infinity. So the minimum output is going to be 2. So from 2, including 2, that's why we have a bracket, up to positive infinity, and then a parentheses. Type of discontinuity. We actually have 2 discontinuities. We have a jump at x equals 1, and if we think of the other one, which other one are we looking at? If we kind of look back at the pictures here, and hopefully I'm not flinging them too far, not infinite, removable. It's kind of like this picture right here, okay? So we have a removable, one more slide, sorry, removable at x equals, let's see, this one's right at 3. So we have the type for each and at the input where it occurs. That is the location. Okay, students, please make sure to write down any questions you have. We will do a lot more practice with this. So if you are in the pit right now, it is absolutely fine. I'm not expecting you to have mastered this, but it's good if you went through this before class. Hopefully that'll give us a little bit of a jump start when we get together. Okay, thanks.